Now let's look at graphing polynomial functions by putting all of this together. Graph the following polynomial function, defined by f of x equals 1/4 times the quantity x plus 1 squared times x plus 2 times x minus 5, by finding the following: the degree of the polynomial, the end behavior, the number of turning points, the y-intercept, and the zeros in their multiplicity. So for the degree and end behavior, what I'm going to actually do is figure out what the leading term is of this polynomial using the cool little trick that I taught already. So that leading term is going to be 1/4 times x squared times x to the first times x to the first. So that gives me 1/4 times x to the 4th power. Okay, so that means the degree is 4. The end behavior is going to act like that leading term. So the end behavior is going to be like y equals 1/4 x to the 4th power. So this is an even powered function with a positive coefficient. So that means it's going to look like that. In other words, we can notate that more mathematically as x is going to approach positive or negative infinity, your function is approaching infinity. The maximum number of turning points. So we stated that the maximum number of turning points is 1 less than the degree, or the degree minus 1. So 4 minus 1 is 3. The y-intercept. So the y-intercept happens when your x value is 0. So that's plugging in 0 for x. F of 0 equals 1/4 times 0 plus 1 squared times 0 plus 2 times 0 minus 5. Simplifying this up, we get 1/4 times 1 squared times 2 times negative 5, which gives us 1/4 times 1, because 1 squared is 1, times 2, which is 2, times negative 5, which is negative 10, which becomes negative 10 over 4, which reduces to negative 5 over 2. To find the zeros and their multiplicity. So the zeros of a function are going to be, again, those x-intercepts are where the function is going to equal 0. So I look at each factor. So 1/4 can never equal 0. I'll do this in purple. X plus 1, that's going to equal 0 when x is negative 1, and that has a multiplicity of 2. So that means the graph is going to touch at that x-intercept, or that 0, because it has an even multiplicity. The next factor, x plus 2, gives me a 0 of negative 2. That has a multiplicity of 1, which is an odd multiplicity, which means the graph will go through there. X minus 5, that's going to equal 0 when x is 5. Multiplicity of 1, which means I'm going to go through there. Okay, now I should have everything I need to actually create this graph. So we'll create our x and y axes. Okay. Okay, so let's put all the points that we know. So I know that this graph is going to have these zeros of x is negative 1, negative 2, and at 5. And we have a y-intercept at negative 5/2, which is negative 2.5. So now I've got these points. And this is where the end behavior really helps. So you kind of just use all these little tools that we just figured out. These are like our tools in our toolbox, all of these pieces. And now we'll put them all together to graph this graph. So we said the end behavior is going to look like this. So that means on the left-hand side, I'm going towards positive infinity. And on the right-hand side, I'm going towards positive infinity. And once we have that, then we just connect the points. So this has to go down to this x-intercept. And at -2, I go through. So that means I've got to go down and then back up somewhere. So you just kind of sketch it. It might go down all the way down here, but I'm just going to have it go down there. Back up to -1. At -1, I touch. So I'm going to just touch it. So that means it has to go back down. It's not going to go through. It has to just go back down. We'll go to that y-intercept. And then I've got to connect to this x-intercept. So at 4, or at 5, and I go through, and I can connect right to there. So there's kind of my sketch. So again, it's putting all the pieces together and looking at what this is going to end up looking like. And this is where the end behavior really comes into play with helping you know where to start. And the multiplicity really helps with knowing what you're going to be doing at each of those x-intercepts. Now again, this is just a rough sketch. Let's look at another example. Let's look at this polynomial. So first let's find, we need to find the degree, which again can be found by finding that leading term. So our leading term is going to be -1/2 x times x to the first times x cubed. And that becomes -1/2 x to the 5th power. So our degree is 5. Our end behavior will be like that leading term. So that means I'm going to behave like an odd power function, and because I have a negative coefficient, it's going to look like this. So that means as your x's are approaching -infinity, your function is approaching positive infinity. And as your x's are approaching positive infinity, your function is going down towards -infinity. Max number of turning points is 1 less than the degree. So 1 less than 5 is 4. The y-intercept is f of 0. So plug 0 in for x. And we get -1/2 times 0 times 0 plus 3 times 0 minus 2 cubed, which is 0. And then for the zeros of the function, so this first factor is going to equal 0 when x is 0. That has a multiplicity of 1. Because again, this factor is basically to the first power, even though it doesn't show that, which means that that 0, the graph will go through. This factor is going to equal 0 when x is -3. That also has a multiplicity of 1, which means the graph will go through. And then this has a 0 at 2, which is a multiplicity of 1, which means the graph will also, or sorry, multiplicity of 3, because that was to the 3rd power, which means the graph will go through there. All right, now I should have enough to graph this. All right. So I have points at 0, -3, and 2. And I know with my n behavior that on the left side I'm going down, or I start from going towards positive infinity, but then I go down. And on the right hand side I'm going down. So now let's see what's happening in the middle parts. So at this x-intercept, do I go through or do I just touch it? So at this one's x equals -3, so I just go through. So that means it's going to go through, it'll go down somewhere, and then at some point it has to come back up to this next 0. So at that 0 at x equals 0, I go through, so that means I have to go up here somewhere. And then I come back down to hit this next 0. And then hopefully I go through. I better go through since I know that this has to go down towards -infinity, so let's just double check. At x equals 2, I do go through. So those are a rough sketch of this polynomial function.